For a problem like this, when we're having to rewrite into an equation format, what we're trying to do is we're trying to identify the different parts. So remember, in a problem, you want to identify a coefficient, you want to identify a constant, you want to identify the variable, and now, because we're writing them as equations, you need to identify what it's going to be set equal to. So some quick reminders, again, when we're talking about a coefficient, there are some key words that we can look for. Who remembers what one of those key words or phrases was? Actually, I'll give you an example of one of them. Maybe if I tell you one, you will remember, but one of the words is per. Anybody remember what some of the other ones are? Abdullah? Each. Okay, and then there was one more. Anybody remember what the last one was? Per, each, and... Anybody? Nobody? Every. Per, each, and every. I know it's been a little bit of time since we've done that. So we're looking for keywords that say per, each, or every in the word problem. Okay? Now your variable is also going to be attached to that value. Your variable is also going to be attached to it, but it's also going to be stated in the question. It's related to the per, each, and every, but it's also related to it in the question. So you always want to make sure that you're reading the questions very carefully in order to identify what the variable is going to be represented as. Okay, then we've got our constant. And our constant happens to be a one-time value. So it might be a starting point. It might be a one-time fee that you're paying, something that is a one-time value. It only happens once. And then, of course, what you set it equal to would be a total. So the value that it equals is going to be something that represents a total amount that you are paying, or a total cost, or total number of messages, or total of some sort that it's set equal to. Okay? So let's go through this very first problem. You always want to read the problem in its entirety. Then you want to go back and look at what the question is asking and then piece these things together. So it costs $12 to attend a golf clinic with a local pro. So if you're wanting to go and attend this golf clinic and be taught by a local pro, you have to pay $12 just to go. Then you have to pay for buckets of golf balls. So in order for you to be able to practice hitting, you have to buy a bucket of golf balls to practice with. And the bucket is going to cost you $3 each. You are going to spend $30. That's the most that you're going to spend for the entire clinic. So we want to write an equation that's going to represent how many golf buckets, B, that we can buy at the clinic. So right now, in the question is telling me my variable. What is my variable? B. And what does B represent? Buckets. Buckets of the golf balls, right? It represents how many buckets you can purchase. The question is asking how many buckets. That represents our variable. So the variable is the buckets of balls. And we're going to go ahead and let that be represented as the variable B. Okay? Now the coefficient. Coefficient, we're looking for keywords like per, each, and every. Do we see per, each, and every anywhere? Jeremy?
Yes.
Where?
Okay. The clinic costs $3 each.
Yeah, it's $3 each. So the buckets of golf balls are going to cost $3 each. So that 3 is going to be our coefficient because of the word each. We see that word each. So $3. $3 for the cost of the golf balls. Okay, the constant, it's a one-time value. Do we have a one-time value that we're paying? What? What's the one-time value that we're paying? To be able to attend, right? Just to show up, you have to pay an entrance fee. It's kind of like, how many of you have ever gone to a fair? Okay, to get into the fair, you have to pay an entry fee, right? You pay entry fee. Oh, I'm going to pay $5 to enter the fair. But then if you want to ride the rides, you got to buy tickets, right? So you pay the entry fee one time because you're only entering one time. Then however many rides that you're wanting to ride, you pay those over and over and over again. So it's kind of like this. To get into the clinic, you pay a one-time entry fee. It's $12. Shh. You pay that one-time entry fee in order to be able to get into the clinic. So that is our constant. You pay it once. That's it. Now, what do we want the total to be? $30, right? He's going to spend no more than $30. $30 is the amount that you're going to be spending. How much you're spending for the entire clinic is going to be $30. That entire clinic is going to be the price of entering the clinic and then the price for the buckets that you are buying. So we want to know, based off of the fact that you're only spending $30, how many buckets are you able to buy? Buckets full of those golf balls to be able to, practice with. So now we got to write this up. It cost us $12 to enter the clinic, plus it's $3 for every single bucket, and that's going to be set equal to 30. So that's our complete and total expression. Angel, your computer should not be open. Okay. Rohan, go ahead and close your computer now too. It's okay. You'll do it another time. You'll finish it another time. Okay. Just don't turn it in yet. Just wait. Okay. All right. So for here, we've got $12 to enter, $3 per bucket, and it's going to cost us $30 at the end. So now we can go ahead and solve just like normal. What would we do to solve this first? If this was our expression, what would we have to do to be able to solve it first? Daniel, what do you think? And what are we going to subtract? 12. So to solve it, we would subtract 12 from both sides of the equation. That's going to leave us with that 3b. And that's now going to be equal to 18. And what's our last step to do here? Jeremy? Divide by 3 on both sides. Okay, and when we divide by 3 on both sides, we're going to get b is equal to 6. And again, 6, it's 6 what? We always want to reference it back to the problem. 6 buckets. Thank you, Angel. It's going to be 6 buckets. So we can purchase 6 buckets when we go to that clinic. Okay, so all you are doing, you are identifying coefficients. You are identifying them by finding those keywords per each and every. Typically, that's associated with it. You're identifying your variable because your variable is also associated with per each and every, but it's also in the question. The question will tell you or state to you the variable. It might not give you the letter, but it will say something like how many buckets. Okay? The constant is that one-time value, an entry fee, or a one-time payment, or how much you are starting with in your bank account, or how much you're starting with on a gift card. And then how much it equals is the total amount that you're planning to do at the end. Okay? So let's take a look at problem number 2. Jessica wants to save money so she can buy tickets to go to a concert. The tickets cost $405, and she's able to save $45 each week as a dog walker. We're going to write an equation that represents how many weeks it will take for her to save enough money for the concert. Okay? So we want to know right now how many weeks, W, that's my variable. My variable is going to be W, which is representing the weeks. How many weeks is it going to take for her to raise enough money? Okay, 405. It costs $405 for the tickets. What is that going to be? She wants to save up enough money to buy the tickets. So this is the value that it's going to be set equal to. This is how much money she needs to save. We know that she has to be able to save up enough money so she can buy those tickets. That's $405. That's going to be what it's equal to. It equals 405. Okay, now 45. $45 is attached to an each. 45 is attached to an each. That makes it a coefficient to my variable. So do we have a constant in here? Does she have an amount of money that she's already saved? Yes or no? No. There's no amount that she's already saved up. So we have no constant in this case. Sometimes you don't have a constant. Sometimes you don't have a coefficient other than 1. You have to make sure you're reading these things very carefully. So our coefficient in this case, because we saw the word each, that's going to let us know it's 45. So when we set this equation up, it's 45W, because your coefficient always gets paired with your variable. And it's going to be set equal to 405. We have 45W is equal to 45. From here, this is where we start to solve. We would just divide both sides by 45. Okay, so if you take 405 and you divide it by 45, how many weeks is it going to take for her to be able to raise enough money? 9. Okay, you're writing them, translating the word problems into an equation, and then you're going to go ahead and solve the equation. Let's do another together. Paulo has $145 in his savings account. He earns $36 a week mowing lawns. If Paulo saves all his earnings, after how many weeks is he going to have $433 saved up? Okay, so in the question, if Paulo saves all of his money, after how many weeks? There's my question. How many weeks? So what's my variable going to be? W. How many weeks? Weeks is going to be my variable. My variable is weeks. So we're going to use the word W, or the letter W. After how many weeks? There is my variable. Okay, let's identify our coefficient. Do we see anything that's kind of similar to per, each, and every? He's got $145 in his account already. He earns $36 a week. Can I say $36 each week? Can I say each week? Yeah. Can I say per week? He earns 36 per week. He earns 36 every week. That word A, it's a little, you got to manipulate it a little bit. You got to look and go, well, could I say 36 each? 36 per? 36 every? Yes. This is a term that you could do. So $36 a week, it's attached to my variable. My variable is weeks. It's attached. So there's my coefficient. It's 36. So when I write my problem, I'm going to have 36W. I know that part. Okay, my constant. Do I have a one-time starting value?
Yes.
What is it? What am I starting with? I started with $145. He already has $145 saved up in his account. So from there, he's going to continue saving $36 every single week. And what does he want to have at the end? How much total does he want to have saved? 433. He wants to have $433 saved up. So there's your total. That's what it's supposed to be equal to. Okay, from here, we would then go ahead and solve. Vincent, what do I have to do first to solve this? What do I need to do first to solve? So we don't have distributive. We don't have combining like terms. This is just now solving. What's the first step that we need to do to solve it? Subtract. And what are we going to subtract? Well, that's multiplication right here, so that's not the inverse. We need to subtract our constant. Our constant is 145. We're going to subtract the constant from both sides. Okay, that's going to leave us with 36W here. And when we do 433 minus the 145, that's going to give us 288. Okay, after that, our last step is to go ahead and divide both sides by 36. We're going to divide both sides by 36 so that we can find out how many weeks it's going to take us. So if we do 288 and divide it by 36, what do we get? 8. So it's going to take us 8 weeks to be able to save enough money for what we're wanting. All right, here's something that's pretty common. You go shopping and you spend some money and you need to figure out how much money it costs on something. So Kelsey is going to go to the mall. She bought some new clothes. She spent a total, keyword, total. She spent a total, so that's my equals value. She spent a total of $140.49. So I already know what my total is going to be. I know what it's going to equal. I know I have an equation that's going to equal 140.49. So I'm even going to write that up here. It equals 140.49. Now I got to figure out what my equation looks like. She bought 1 pair of jeans and 3 shirts. She bought 1 pair of jeans and 3 shirts. Now, the jeans cost $54.99. So she bought only one of those. So that's a one-time value, isn't it? If she only bought one of them, that's a one-time occurrence. So my constant in this case is the price of the jeans. She spent $54.99 on jeans. And on top of it, she bought 3 shirts. Do we know how much the shirts cost? No. But we do know she bought 3 of them. So there's my coefficient. Because she bought multiple shirts. Multiple shirts. Coefficients are multiples of items. So there's my 3. What we don't know is how much the shirts cost. The question is telling us the variable. How much does the shirt cost? So we want to know the cost of the shirt. So my variable is going to be a cost, or C. I want to know how much the shirt cost. And I bought 3 of those shirts. So we have 3 shirts at a cost of an unknown value, plus 1 pair of jeans, which was $54.99, and my total comes out to $140.49. We can then start solving. We're going to subtract $54.99 from both sides. Okay, that's going to leave us with 3C is now equal to how much? What's 149.49 minus 54.99? $85 and not 0.5, but $85.50. It's $85.50. Okay, now we need to figure out just the cost of one of those shirts. So we're going to divide both values by 3. So take your $85.50 and divide it by 3. How much did just one shirt cost? Go ahead. $28.50. $28.50 per shirt. Okay, that's the cost of just one shirt. It was $28.50. Okay, we've got 4 more practice problems on the next page. I want you guys to go ahead and try those problems on your own. What I am going to show you is what the equation will look like and then what your answer should be once you've solved it. So that way you can go ahead and map it up. So for here, it says Juan's cell phone company charges $35 a month. That's our one-time fee. Okay. Plus 50 cents for each text message. 50 cents for each text message. That's going to be our coefficient and variable. The variable is the amount of text messages. So I'm going to use the variable M to represent the messages. And he's going to have a total bill. His final bill is $52 for the end of that month. So when I set this up, my equation is going to be set up as 0.50, because it's 50 cents per message, times M for the number of messages, plus $35 for his one-time payment on that month, and he spent a total of $52 that month. Okay, that's the equation. That's what the equation looks like. When you solve it, if you solved correctly, then the number of text messages that he sent that month were 34 text messages. Sent 34 text messages. Okay, you would subtract 35 and then divide by 0.50. All right, for number 6. Northbrook Middle School soccer team purchases uniforms and equipment for $912. The equipment is $612. Uniforms are $25 each. How many uniforms? So how many uniforms? There's our variable, U. It costs $25 each for the uniforms. So 25 U. They also spent money on equipment, which was $612 total, and they purchased all of that together for $912. So you should have gotten 25U plus 612 equals 912. When you solve it, you would find that the number of uniforms were 12. They had 12 total uniforms that they purchased. 12 total uniforms that they went ahead and purchased. Okay, for number 7, this is a common thing. In fact, we just had somebody come out and do work on our house. A plumber charges $75 just to come to your home. Okay, they make a lot of money, guys. They charge $20 or $75 just to show up at your front door. Not even do any work. Just $75 just for them to get there. Then it's $25 for every hour that they spend at your house working. So they make a lot of money. So $75 is a one-time value. You get charged it just for them to come to your house. Then you pay $25 per hour that they spend working. So we want to know how many hours if he charges you $200. So when we write this out, the equation is 25. Don't talk. It's $25 per hour plus the $75 just for them to show up at your house, and it costs you a total of $200. So when you subtract 75 and then divide by 25, you find out that he was at your house for 5 hours. So he did 5 hours of work. Okay. Now, the last question, the fare, like I told you guys, costs you $12 just to enter the fare. That's a constant. You want to ride rides, so you got to buy tickets. Each ticket is going to be $2. Each ticket is $2. So how many tickets did you buy? So $2 per ticket, T, plus 12. I didn't tell you guys to get up and start walking around. Sit down. $2 per ticket plus $12 to enter the fare, and you spent a total of $62. So 2T plus 12 is equal to 62. Once you've solved it, you subtract 12 and then divide by 2. You go ahead and you purchase 25 tickets. You purchased a total of 25 tickets. Okay, now you may pack up.